Salam and hello everyone. Today we're going to be working on joint Lewis structures of the molecules CCl4 and NF3. The important thing I need to tell you guys is this is mainly for practice purposes, and we're going to be doing a bunch of questions in more videos coming soon. So we've got CCl4, and we're supposed to draw the Lewis structure of this. So the first thing you have to know when you're dealing with Lewis structure is for you to first of all determine the number of valence electron for each atom. We've got 5 atoms here. We've got 1 carbon and we've got 4 chlorines. Well, the next thing is that we're going to determine each one of the valence electron. Well, carbon tends to have 4 valence electrons and chlorine tends to have 7 valence electron. So that 7 is going to be multiplied by 4 since there are 4 chlorine atoms in this question. So we end up with 4 electrons plus 28 electrons. We end up with 32 electrons. So the next thing you do anytime you've determined that is for you to start to draw the skeletal structure, which is just a structure that involves just the atoms connected to each other by bonds. So you've got we've got carbon going into chlorine, another chlorine, and then the fourth and last chlorine. So it's important for you to note that each bond is always equals to 2 electrons. Each lone pair is always equal to 2 electrons. 2 bonds equal to 4 electrons, and then of course triple bond or 3 bonds equals to 6 electrons. So this is just a short recap for you guys. So you've got 4 bonds here. That means we've got 8 electrons. So we have 32 electrons minus 8 electrons, and what we have left is 24 electrons. The next thing you start to do is to start to add lone pairs, making sure you're following the octet rule. So we've got to add lone pairs to wherever lone pairs are supposed to be. Well, we're not going to add any lone pairs on carbon because carbon has 4 valence electrons, and to follow the octet rule, that means you're supposed to be 8 electrons that are basically um, 8 electrons that are basically surrounding carbon, and then 4 electrons that are directly near to carbon. So what I'm trying to say is, since we know that carbon has 4 valence electrons, we've seen that 1, 2, 3, 4. The 4 atoms that are the 4 electrons that are directly connected to to carbon atom basically makes this correct, right? So you've got 4 here. So it doesn't need any form of lone pairs. It doesn't need any other bonding. Everything is working out fine. And when we look at the octet rule, we see that we've got, like I said, 1 bond equals to 2 electrons, 1 bond equals to 2 electrons, 1 bond equals to 2 electrons, 1 bond equals to 2 electrons. There are 8 electrons that are surrounding carbon, and then 4 that are right next to it. So this carbon atom follows the octet rule, and it is confirms that there are actually 4 valence electron because it has to confirm what we already know in the principle, which is 4 valence electron for carbon, and this structure confirms that. So that means the only thing we have to worry about now is the chlorine atoms. So is that understanding you need to know anytime you're working with Lewis structures. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Well, we've gotten 24 electrons connected to it. So we have 24 that was left here before, 24 electrons minus 24 electrons, which is just the electrons we added at lone pairs. So we end up with 0. Anytime you're working with Lewis structure, you want to make sure that by the time you're done subtracting every single electron you've used up from the total, we always want to end up with 0. That's how you know that you've used up all the proper electrons. And you can also make sure that you followed all the principles by looking at your structure one more time. So we've handled carbon. We know carbon is correct. Now we're going to look at chlorine. Well, following the octet rule, for chlorine, we've got 2, 4, 6, and then this whole bond here is going to represent 8. So you've got 8 electrons that are surrounding chlorine. But then how many are we supposed to have that is right next to chlorine? Immediately next to chlorine, we're supposed to have 7 electrons because the valence electron for chlorine is 7. So how do we show that we know that that is what is going on? Let me use the color green. So what we end up with is 1, 2, 3, 4, 5, 6, and then 7. So we've got 7 valence electron. So now that we've done this, we already know that we've done it right. we're not going to have any charges in this particular structure. We've done everything right, and we've counted that we've used up all the 32 electrons, and we have put the correct number of valence electrons right next to each atom, and then we followed the octet rule for each atom in the molecule. And that's how you know that your Lewis structure is 100% correct. So I'm just going to redraw this to have C, Cl, 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 and then Cl. And you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And this is the Lewis structure of CCl4. So the next one we're going to do is the NF3, which is nitrogen and then 3 fluorines. Well, we've got four atoms here. We've got 1 nitrogen and we've also got 3 fluorines. So that would be 1. And we've got the valence electron for nitrogen is 5, right? So it's got 5 valence electron, and fluorine has got 7 valence electrons since it's an halogen. So we have 7 valence electrons times 3, because that's the number of atoms that we've got, and we end up with 5 plus 7 times 3 is 21. So we end up with 26 total electrons. So now we do the next thing that I taught you guys. We are going to draw the skeletal structure of just the atoms connected to other atoms, or sorry, just the atoms connected to each other with bonds only. So you've got nitrogen and you've got fluorine, fluorine, and then you've got fluorine here. So you've got 2, 4, 6. We've used 3 bonds, and that's equivalent to 6 electrons. So you've got 26 electrons minus 6 electrons. So you've got 20 electrons left. The next thing we've got to do is to make sure that everything we have is basically balanced. Well, we've seen that the number of valence electron for nitrogen is 5. So let's count how many is directly connected to nitrogen. We've got just 3 that is directly connected to nitrogen. Hence, this is not following the number of valence electrons principle. Let's also check the octet rule. Well, the octet rule is supposed to have 8 that is surrounding nitrogen, not necessarily next to. We've got 2, we've got 4, we've got 6, we're supposed to have 8. So we're 2 electrons short in both the valence electrons as well as the octet rule understanding. So what that means is that we're going to add a lone pair here, and then we're going to recount it. So you've got 1, 2, 3, 4, 5. So this is good. We've got the fact that 5 electrons are directly next to nitrogen, meaning the number of valence electron matches the structure. And then we're also going to look at the number of bonds. And sorry, we're going to look at the octet rule. So we've got 2, 4, 6, 7, and then 8. So we've got 8 electrons. They follow the octet rule. So that means nitrogen is all clear, because nitrogen being drawn that way is correct. And I promise you guys, if you guys can look at questions like this in chemistry, of course, if you're not dealing with hypervalent questions or atoms, sorry, if you're not dealing with hypervalent atoms, you guys will see that this principle works all the time. So now we've added 2 more electrons. Sorry, we've added 2 more electrons in form of lone pair or nitrogen. So we have 20 minus 2. You're going to have 18 electrons left. So the next thing we have to do is, since we know that there are supposed to be 7 electrons around fluorine, which is going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, we've used all 18. So 18 electrons minus 18 electrons. So we've got 0 electrons. So we fulfilled that, which is good. Now we have to go back to our structure to make sure we did it right. We see that we've got a fluorine atom is supposed to have 7 valence electrons surrounding, sorry, 7 valence electron next to fluorine. So we've got 2 here, 4, 6, and then this one right next to fluorine, which is 7, 2, 4, 6, and then 7. So the valence electron understanding for fluorine is perfect. Then the next thing, of course, we have to do is to make sure it follows the octet rule, which is looking at all the electrons surrounding fluorine, not necessarily just the ones right next to it. So we've got 2 from the bond between nitrogen and fluorine, and then we've got 4 here, 6, and then 8. So you've got 8 electrons surrounding fluorine and then 7 electrons right next to fluorine. So you end up seeing that both the octet rule and the valence electron principle follows. That means your structure is correct. So we're going to redraw the correct structure. And you've seen that this structure is very correct. And that's how you work with Lewis structure. Please watch more videos on my channel because they're going to be a lot of practice. I wish you guys all the very best. Assalamu alaikum.